is Ulises Reyes. So I'm going to start with a quick poll. So have you ever launched an application or started an application from scratch, from nothing, and taken it all the way to production with paid customers? Cool, cool. All right, a couple of hands. Really cool. All right. So I'm very lucky that I've been part of this journey in DataRobot. I joined DataRobot 5 years ago, and we took our application, our prototype, all the way from zero, basically, to what we have today. So today I'm going to share with you our story and a couple of practices that we implemented along the way, a couple of mistakes that we made, some lessons learned, and hopefully this could be useful to you. So first things first. Okay, good. I thought I misspelled my name. No, that's me, Ulises Reyes. I'm a software engineer. I've been doing this for 12 years. 7 of them were actually working on .NET, and believe it or not, I actually got into Python only 5 years ago. Been a happy man ever since. Currently, I'm a VP of engineering in DataRobot. So I'm just going to tell you something real quick about DataRobot. We enable AI-driven enterprises. We automate machine learning, and we have only one product. Now, we ship this product to the enterprise, and we also host our product in the cloud. So we have our own SaaS. And this last point is the one that is, I guess, relevant to the conversation. All right. So I guess before I tell you how this talk structured, I just wanted to let you know that I'm not going to show you any source code, but I like to let you know that probably 95% of our source is written in Python. So the actual runtime, what powers our application, is Python. And most of our automation scripts are also Python. So we're definitely a Python shop. So basically, I'm going to break this talk into 3 phases. And the very first one is our humble beginnings. Then I'm going to tell you about the stage where we started implementing continuous deployment. And then the third one, which is my favorite, our effort in order to unify our platform. So like I mentioned, we have our enterprise product, we have the cloud, and it got to a point where we actually needed to maintain only one thing. Also, along the way, I'll be sharing some of our lessons learned, some of the mistakes that we made, a couple of practices that we implemented, and hopefully you find them useful. All right, so the very first one, our humble beginnings. So DataRobot at the time was very small, less than 15 people. We didn't have any users. So we just needed the app to work on the cloud. So basically, we didn't have many requirements. It just needed to run there. And the reason is that at that point, our application was mostly used for demos by our CEO. So there was nothing else going on. In terms of our team, in terms of our engineering, so there were very few of us. We wore all kinds of hats. We did backend UI and some DevOps, whatever that means. Now, something interesting is that only one individual out of the entire team knew how to deploy to production. The rest of us couldn't care less. So yeah, that's fine. No big deal. Now, in terms of automation, we were very, very focused on continuous integration and automated testing. So that was something that, from day one, that was very, very important for us. And since we were a Python shop, so it was very natural, I guess, for that one developer who wrote all of our automation to deploy to the cloud to use Python and Python Fabric. We didn't have that many deploys. As I mentioned, it was mostly whenever we had a demo. So we actually had a warning, probably a couple of days in advance, and it took, hours and hours of troubleshooting to get it working. And it was done from this developer's laptop. Now, we didn't have staging. We only had one environment, and that was production or beta, I guess. Yeah, that's fine. So let me tell you a little bit about the processes that we had back then. Very simple at this stage. Everybody is responsible for everything. You break it, you fix it. That's simple. All right, so I'm going to tell you a little bit about the architecture of our application at a super high level. So basically we have a client. The majority of our application is written in, the front end is written in Angular. We also have a RESTful API. And basically the UI interacts with some of the web services, mostly Python. There's only one bad boy written in Node.js, no big deal. And our application tier talks to our broker, and the broker is in charge of sending jobs to our workers. And that's where the magic happens. So that's DataRobot. So this is our storage layer, nothing crazy. So back then, our deployment view, how the application was actually in the cloud, super straightforward. Most of our services were combined into a single box. We had one box dedicated for the broker, and we have, individual workers. Probably back then, maybe we have only like 20 instances for the workers. All right, so deployment strategy. Here's where we start getting technical. Are you guys ready? That's pretty much it. From the laptop, we deployed to the cloud. It was just as easy as that. We didn't have any automation. We didn't have any staging. We didn't have anything going on. So it was just this guy working on trying to deploy to the cloud all day long. So a couple of lessons learned from this stage. We did have a buzz factor. We only had one person who could deploy to the cloud, but it wasn't really a big deal. Our Python tool was super flexible. You could do basically anything you want with Python and Fabric. At the same time, it was actually very complex. But then again, it wasn't a big deal either. It was only one person who worked on it, and it wasn't me, so who cares? It was very important back then that even though we had just getting started, we had a culture of automated tests for everything. So that was very important. It was key. All right, so next phase, the continuous deployment era. At this point, the company is probably less than 50 people, and we have a few paid customers. So actually, I wanted to point this out because every time that I hear, or every time that someone talks about continuous deployment, the first thing that they say is, yeah, if you're continuously deploying to your cloud, probably you don't have any customers. So we did. The idea back at this stage, it was deliver to the cloud as soon as possible. As soon as you complete a feature, you wanted to see it in production the same day. Well, at least the stakeholders wanted to see it working in production the same day. Even though nobody ever told us this, at this point, I would say that our agility was more important than stability of the application. And cool fact, it was that the idea of continuous deployment was actually suggested by our CEO, Jeremy. He basically wanted us to be more agile, more efficient, and he heard about continuous deployment, so he invited a consultant, and he came over and gave us some training. Another interesting point at this stage is that, so we're starting to get our cloud right, but then at the same time, we started building our installer in order to deploy DataRobot to the enterprise. So these were two things that were happening basically at the same time. In terms of the engineering team, still very small team. Everybody did everything, so there was not much organization, I guess. We had a couple of DevOps teammates, and they still were not the only owners of the cloud. And in terms of automation, so the ultimate goal was to have continuous deployment. All the way from your laptop, you make a commit, and then you see it in the cloud. That was the ultimate goal. As the first stop, the idea was, all right, let's put all the automation in place, and let's have one-click deploys. So we can see it in staging, and then if it looks good, then we can send it to production. Now, one interesting thing that we did here is that we actually replaced our tool and started using more Ansible. We still had a lot of Python wrappers and Bash wrappers, and sadly, we didn't have many tests. Even though we were all about testing, but not for deploying for whatever reason. So yeah, we didn't have tests there. We started using Jenkins in order to automate all this, the deployment. And we added a new staging environment. From the get-go, we enabled continuous deployment. So whenever we committed to master, it went to staging, and it deployed multiple times a day. At this point, we started playing around with Docker in our deployment because we wanted to minimize the downtime of the deploy. When you're using Docker, you restart a container very quickly. So the idea here is, all right, so if we're deploying in place to the same environment, can we do it fast? Can we restart containers and probably nobody notices that it happened, or so we thought. We also started using autoscale. In order to improve, the availability. Many times we needed more workers, so instead of running all of our deployment, we just started using autoscale. So in terms of processes, so the idea here, or the mentality here was move fast, break everything, fix things quickly, but move fast. And continuous deployment was a new process that actually gave us a lot of new tools or a lot of practices that were fairly new to the team. And one of them was feature flags. So as you may know, feature flags is just a mechanism for you to show or hide features in your application. And you can do it depending on cluster settings, so you can do it on user permissions, you can do all kinds of things. Very straightforward. The other thing is we started to realize that if you change basically, or if you deploy multiple versions of the application, you could have backwards compatibility issues. So that sounds kind of obvious, but it was definitely interesting the first time that we had to roll back our application. We created a Slack channel called War Room, and I'm going to tell you a little bit about it in a couple of minutes. And also we started doing postmortems. Quick poll, how many people do postmortems here? Oh, wow, lots of people. All right, I'm still going to go through the slides. Lots of people. All right, deployment view. Pretty straightforward, basically the same, just more services into, we split the services into more boxes, but it's basically the same. Now, deployment strategy, now we had Jenkins. And the idea, like I said, is you commit to master, and we run some tests, and then we build, which was really just package, deploy to staging. Now, as I mentioned, this was continuous deployment. We ran some more tests, and then we deployed to production. Now, initially, we put the brakes there so we could have one-click deploys. So before we move to phase 3, so this was a quick summary of phase 2. I just would like to talk about a little more about these practices that we implemented, and the first one is continuous deployment. So this is just how we did it. It's by no means how you implement continuous deployment. This is how we happen to actually do it ourselves. And one of the guidelines that we had was everything has to be tested, and you need very fast test. And the reason is we encourage everyone pushing straight to master. So you needed to run your tests locally, and then as soon as they were green, you were good to go and push to master. Basically, if you broke something, the idea was, well, go back and write a test for whatever you broke, and start again. So yeah, we're pushing straight to master. No pull requests. And if anyone happened actually to create a pull request, the worst that they could have done was to have a pull request that lasted for multiple days. So pull requests were bad, bad, bad. And the idea was, okay, so you push to master, and then after the fact, maybe in your free time, you take a look at the master history and then review the commits after the fact. And if you saw something, then maybe you will either fix it, write a test, or tell someone else, or whatever. But the idea was, yeah, go fast, fast, fast. And we were actually deploying to production multiple times a day. And it was then very important that we also needed to have an ability to roll back. Mistakes were made, and that was actually key on that point. All right, so here's the good about continuous deployment. It actually changed our mentality, so we were always ready to ship. That was the main idea. And also, we learned that you can only do continuous deployment if you have fast and reliable tests that actually catch bugs. So here the idea was that if whenever we had an issue, the question was, okay, what test did we miss? You know, how come our tests were green and we still had this problem? So we had to go back and write an end-to-end test or do something so we could avoid the same issue next time. Another cool thing is that our deploys were fully automated. So it sounds, I guess, obvious, but you realize how much work that is until you actually get to have, you know, a fully automated deploy, you know, from end to end, from your laptop all the way to production. And also we realized that feature flags were super, super helpful. You know, we were able to do beta testing. Basically, we were gradually, with continuous deployment and feature flags, gradually building our features, shipping them to production, and even though they were halfway complete, we would enable them only for us, for the developer, and once you were happy with it, maybe you would share it with another developer, maybe you have a group of people that they said, yeah, it looks okay, and then we would enable it for all of our users. So yeah, that was pretty cool. More awareness, I guess, on backwards compatibility. I think that was a good thing that we learned from continuous deployment. We were going fast, and at the same time, you know, we were also rolling back from time to time. And sadly, we got used to having postmortems. Yeah, there were postmortems left and right. All right, so the bad. The way that we were doing this, it actually took a lot of coaching. Every time a new engineer joined, we need to sit down with them and explain, look, we're doing continuous deployment, you push to master, but so we had to explain everything, and it was very difficult to scale. Also, nobody was, I don't know if I was the only one doing reviews on master, but nobody was doing that. Master was broken all the time. And actually, our deploys were not zero downtime, so every time we were deploying multiple times a day, but every time there were like, you know, little blips. Like if you happen to use the application at that point, probably you got a 502, and that happened all day long. And you only need one of those, right, for the CEO to have a demo, and yeah, things go bad. Also, even though as we started to improve and make things better, avoid mistakes, and have quick deploys and whatnot, really our customers didn't appreciate very much that the UI was changing so rapidly and without notice. Now you can still do continuous deployment and fix this issue, but at that point that was something that basically we just said, yeah, continuous deployment is doing that to us. So this is basically, if I could like summarize pushing to master, this is basically what it was. People were just like pushing and say, yeah, since it is behind a feature flag, it's okay, nobody's gonna use it, I'll just write a test later, and we're like, okay. Yeah. All right, so a couple of thoughts on the comment that I made about replacing our tools. So Ansible was great. We were very happy with the new automation, but you know there were also a couple of things that didn't go well. So first of all, or the first, I guess, drawback is we had thousands and thousands of lines on the very first tool. So just throwing it away was tough. We had to get together, explain to everyone, or especially that person who had written all that code, and we had to convince ourselves and basically everybody be on the same page. So yeah, this is very true. You cannot just say, hey, listen, this tool is better than this one, so therefore, no, there was a lot of convincing there. Our cost went up, and even though this sounds super obvious, it was something that we just didn't think about. We now had staging. We had another environment that was up and running all the time, and it definitely affected our cost. And also some of the dynamics changed. Now we had a new set of tools. New person contributed to that. So the old person that was actually working on deploys, he wasn't working that much on the new tool. So basically some of the dynamics changed. All right, so just postmortems real quick. It looks like the majority of you know how postmortems work. So every time that we had downtime or there was like a blocker ticket or anything that was kind of a big deal on the cloud, we had a postmortem. So we would get together face to face and go over the usual 5 whys, try to figure out what happened. Here's the main idea of what we always wanted to tell everyone. There is no finger pointing. It's all about process and systems. It's never about people. So even when we were writing the report, we would use the team thought it was a good idea, or we did this as opposed to XYZ person. Lots of action items. Those are the most important things. So a couple of things from the postmortems that we learned. Nobody's really dying to do a postmortem. They're not like the most fun thing. But consistency is key. It's absolutely key. You don't want to do a postmortem only on the biggest fires or cherry pick them, the ones that you think that need a postmortem. You definitely need to be consistent. You have to have a rule and do your postmortems always. Now, creating this blame-free culture it is a lot. It's easy to say, but very difficult to actually implement. It was very, very difficult to moderate in the early days. Following up on the action items is very, very hard. So, fires are unexpected, of course. Oops. There you go. Fires are unexpected. And the action items, of course, are also not planned. So, you have your sprint, you have your release, and then suddenly you have this fire, and you have to not only fix it, but then write a test or modify whatever, caused the fire. And it's very, very difficult actually to follow up, or at least it was for us to follow up on these action items. The reports that we created out of the postmortems were very valuable. We used this actually to share them with stakeholders. It was a very nice, concise summary of what happened and why. So they were actually very, very useful. So I mentioned that we created this Slack channel that we call the war room. So basically, every time that the channel blinked, it means that the house was on fire. Basically, something happened to production was down, there was an issue, and everybody knew that we needed to work on it. So the first goal, or the first thing that we needed to do, was just to contain the situation, fix the issue, and then move it off of the channel, so go somewhere else and continue troubleshooting. So basically, every time that thing blinked was bad news. We have 24/7 coverage. We have a large team in Singapore, Kyiv, or Ukraine, and also Boston. So we had, a pretty good coverage. So basically, this is how I can actually summarize, the nature of War Room. Anytime that we had an incident in production, yeah, I would just die a little bit. All right, so a couple of things, a couple of lessons learned from War Room. So it initially started just as a communication tool, just to have everyone on the same page. But then later it became a hammer for engineering. Basically, if you wanted the attention from engineering, you could put something in there, and all developers would look at it and start working on it. So I guess it was a good thing to have a single spot, to say, hey, the house is on fire. Also a good spot in order to centralize all the troubleshooting. Now, in terms of the bad, or what we didn't like, or what we don't like, since we still have the war room, is very, very disruptive for the team. It could be very messy. So we have, the bug report with troubleshooting, and there was, lots of stuff going on. And another interesting thing, actually, that I was thinking about it the other day is that I think we got used to having a location where we received the report, or we were told that the system was down, instead of putting more focus on monitoring and alerting. So this sounds pretty obvious, but I think we actually got spoiled there with the war room. And maybe, maybe we shouldn't have it in the first place, but we do, so still there. I think it is useful, actually. So with everything that I just mentioned on phase 2, with continuous deployment, pushing to master, and having the war room and all that, basically looking back, this is pretty much how a day in the office looked like. This is pretty much what deploying to the cloud was like. It was just chaos, man. All right. So phase 3. This is the platform unification era, the Pluni era. So at this point, our company is already, I guess, larger, more than 100 people. We have many paid customers. And at this point, the stability is is valued over agility. We definitely do not want to have any downtime. Now, our SaaS, or our cloud, is actually very brittle, and it's very different from the enterprise product. Remember that I had mentioned that we had started already shipping to the enterprise. So the automation that we had, even though it was the same source code or the same application, but the automation that we had in order to build and deploy it was very different from one in the other. Also, one was running on the cloud, the other one was supposed to run on bare metal. So there were some features that we didn't have in one or the other. So there were some differences. So imagine the code was full of ifs, or our configuration had lots of stuff going on to say, hey, if you're in the cloud, you can do this. Or if you're not in the cloud, you shouldn't do that or whatnot. So we just needed we just needed to focus on one single platform, and we needed to reduce the complexity of the code. So we just needed to have like one thing. So the idea here is, all right, let's unify the platforms and let's ship the enterprise release to the cloud. Let's use the same automation that we use, the same installer, and let's put it on the cloud. At this point, the engineering team was around 60 people. We had already organized the entire engineering team into squads. Each squad had a dedicated firefighter. The firefighter, was helping, keeping an eye on war room, or if anything came up, they would help a lot. In the release squad, even though it was a bad name, I think, but we had mostly ops people here, but the release squad was tasked with building the new platform. So back then, we actually didn't have a dedicated cloud team. That came later. Today, we have actually 2 teams that are focused on the cloud. It's a 5-people team, just monitoring the cloud all day. And then we also have another team that is helping us optimize so we can actually use the cloud efficiently, and we have 3 people there. Now, in terms of in the automation, like I said, the entire idea was, what can we do, or what are the things that we need to rewrite in order to deploy the enterprise release to our SaaS? And what we ended up doing, actually, was we got rid of all the Ansible and all the Python that once upon a time that we were super proud of. We got just rid of it, and instead, we replaced it with a tool that was fully tested, and at this point, we had infrastructure as code. So Terraform came in. We're still using some Ansible here and there, but basically, we were relying more on Terraform. And of course, we were using Python as a wrapper. At this point, we also started using blue-green deploys. Quick poll, who is familiar with blue-green deploys? All right, cool. So we started using blue-green deploys in order to ship or deploy to the cloud and minimize downtime. And at this point, the goal was to have 0 downtime, meaning I do a deploy, you are a user, working the application, and you don't even realize that we are actually deploying a new version of the application. So we actually achieved that. And it's actually pretty cool, because the way that we did it is that we launch a complete new cluster whenever we have a deploy. So we launch a new cluster, and here, since it is a brand new cluster, you can just do a security patch or a new operating system. I mean, no big deal. It's whatever you want to do. Just launch a new cluster, and then just change the pointer, if you will, the DNS from the old cluster to the new one, and nothing, and nobody will notice. So that was the main idea. Another thing that happened at this time is, like I said, now we had, I guess, we had multiple squads, some people working on features, some other people now dedicated to the cloud. So we put a lot of emphasis on making sure that databases, logging, dashboards, monitoring, basically all the cloud infrastructure was solid. And in terms of new processes, we switched from continuous deployment to continuous delivery. So instead of deploying constantly, now the idea was, let's be ready always, every single time, but let's have a human decide whether or not it's time to ship. And it was a one-click deploy, but basically we have one person deciding. Now, as the result of all this work that we did, we created a new set of tools that allow us to duplicate production at any given time. So it was actually really cool that we gave the option to developers to say, hey, you want to test this at a large scale, or you want to see how it looks in production? Well, basically just launch another mini production or another production using the tools, and test your code, and then tear it down when you're ready. And then of course, that costs money, so that was a problem. At this point, we have more customers. There are a lot more sales engineers doing demos, so any downtime is super, super critical. So we actually started using incident reports, and I'll just describe them real quick in a second. We started to have formal rotation of firefighters, so basically they're squads. They didn't have a pager or anything, but each squad had a schedule where they said, okay, this week it is your turn, next week it is your turn. So we started having these rotations, and the operations team, they started having pagers in order to have 24/7 on-call rotations. So in terms of incident reports, real quick, here's just, I guess, a centralized place where we say, hey, this is the issue, plain English. Here's a history of everything that has happened with it, a couple of workarounds. And it was just a centralized place where we wanted to keep this information centralized. It was easy for others, for example, other departments, for example, support, or anyone who wanted to know more about what happened. We created these incident reports. We used our ticketing system for this, which is Jira. So I don't know if that was good. It's working so far. The most important thing probably that we discovered here is that for any issue like this, you need to have an owner at all times. Many times these things took multiple days or even weeks working probably multiple squads on one of these issues. You needed one person to be driving at all times. All right. So yeah, so basically give you a summary of everything that we did, but it was definitely not easy at all. There were so many things that we tried and actually that we failed. So it definitely took us a while to get the platform unification right, to get Pluni right. So here's the first attempt. Here's the number one. So I already showed you this pipeline, how we were basically deploying to production. So the number one thing is that we said, you know what, this is now legacy. So we're going to build a new thing. And we thought, well, can we do something in parallel? So whenever we run this test, can we actually execute our enterprise bundle right here and launch a cluster, install the enterprise installer? Can we have it in parallel? Let's launch a new staging. This is going to be called enterprise staging. We run some tests, and then we can deploy to enterprise production. So all that sounds good. So there were a couple of good things from this, and the first one is that this is where all the tooling was created. The tooling is called Dorka. I don't know why. And this suite of tools is basically very well-tested Python code that is used to launch and deploy this cluster. So basically the same code that we are now using to deploy production is the same code that any developer can use in order to deploy any cluster. So this became like the foundation of our automation. However, one of the mistakes that we made here is that this new enterprise cluster was a completely separate environment. So we had legacy, and then we have the enterprise cloud. So we said, okay, we have this new enterprise environment. How are we going to move the customers? So apparently we forgot that part. Also, the deployments to this new environment, they were also in place. So basically the servers were just right there, and you deploy new code and then restarted services. The only problem is that the downtime was actually longer this time. So yeah, that was not good. So after careful consideration of what we had at this point, which is like, yeah, this just didn't work. And you know what? And actually we said, hey, hold on a second. Maybe if we do, we're like, nah, just fucking throw it away. Just start over. All right. So Pluni. So we need to figure out the redeploys thing. We need to figure out a way of not having downtime whatsoever. So that was one thing. And the idea was, hey, can we use blue-green deploys? I read this blog, and these cool guys were doing it somewhere in this popular company. Can we probably do it here in the company? Also, about migrating customers. So how we're going to do it? Doing the migration, like moving the data from one cluster to another cluster, is just impossible. Maybe we can actually use feature flags in order to move people from one environment to the other one. So we had a meeting, we discussed, we brainstormed, and the answer was yes, yes, yes. So we were all super excited, and now we had a plan. So I'm just going to do a super quick overview of zero downtime deploys and how it works. So basically, I guess the key here is that you have a load balancer. You have a way of saying, route all the traffic to this environment. So in this case, it is blue. It is active. And as a step number 2, you actually launch a completely new environment. And as you can see, there are no connection. There are no sessions. It is hidden behind the scenes. You do some testing, and after you are happy with it, and after you know it is golden, it's good, then you switch. So now this becomes the active, and the other one is not receiving new connections, but is still maintaining the old connections. So we still leave it there in place for a couple of hours while it finishes jobs or drains connections, and basically it's completely done. And then we tear it down, basically just to save cost. And now everybody is looking at green. So all this with the idea of, nobody should notice anything while this is happening. So that's the idea of blue-green deploys in general. So yeah, we were like, okay, yeah, so how are we going to do that? So the idea here is, okay, can we make use of that and then at the same time figure out the migration? And like I said, we thought that feature flags could save the day here. So this was the basic idea on how we were going to do the migration. So here's where we are on the left-hand side. Basically, from the front end, you go straight to legacy, right, to the old cloud. So the very, very first thing that we did was just to put this box right here, which is the front proxy. So that was step number 1. Put something in the middle so we could later do some routing. And the step number 2 was, okay, let's launch this new environment just like we had tried before. And here the difference was that we were now pointing, the new application now was pointing to the existing database. So instead of being its own thing, now we were reusing the databases, the file storage. And as step number 3, so what we did was, okay, this is the very, very first thing that we need to migrate. So as part of the new tooling and the new enterprise cloud, we launched more database servers. We added them to the replica set in Mongo. We got all the data, and then we destroyed the old ones. We basically did the same thing with Redis, with the master-slave setup. So basically, we got now this as part of the enterprise environment. And as you can see here, we have still our front proxy, and basically everybody is looking still at the cloud. And I'll tell you a little bit more how we did the routing, but at this point, we basically have 2 environments, and you can connect either to one or the other one, and since both of them were pointing to the same database, basically you could look at your projects in one or the other, and actually you couldn't even tell the difference on which one you were looking at. And so here's where the magic happens. Basically, here we had a way of looking up the customer that came in. So what we did was, in the user profile, we had a checkbox, basically use the new platform unification environment. And when we did that, we obviously marked it on the database, we enabled it, and then also we set a cookie on your session. So what this thing did was, on every request, we would look up your account, and we would look up at your account, realize that the feature was enabled, and then based on that, we would actually send you to either one environment or the other environment. It was actually really cool because it needed to be fast. Imagine doing lookups every time that you have a connection coming in. So we used a module for Nginx in order to use Lua scripts. So whenever something came in, we will have a request to a Python web service. We would cache everything in memory. So it ended up being actually pretty fast. It wasn't a big deal. So then at the end, when everything was done, so basically now everybody was looking at the enterprise cloud, and legacy was finally completely removed. So I'm going to show you in a second the big, or the complete picture. So this is the front proxy that I was describing a minute ago. This is the Nginx plugin, I think that's the right term, that was using this router. So you will look at your data and say, okay, you actually go to legacy or you go to enterprise. So if you go left or right, for left, legacy, pretty straightforward. For right, you would go to this load balancer. And then basically from this load balancer, we were doing the zero downtime deploy, so we will have blue and green. So at some point, we just got rid of this, and then today, we only have this part, the blue-green deploys. So this is how things used to look back in the day, and now, basically just smooth. So a couple of things just to wrap up. A couple of things that we're thinking about. One of them is dynamic scaling. We want to expand and shrink our worker cloud depending on usage, and of course without impacting user experience. For example, if we have jobs in progress, first of all, you don't want to kill that instance, and maybe if you do, you want to retry the job right away. The other thing that we are actually playing around with is actually using DataRobot within DataRobot. So for each job, we predict how much resources this particular job is going to use, how many cores, how much RAM, and then based on that, basically launch that process only with that set of resources. Otherwise, what we do is, since we execute everything in containers, you don't want to use only 1 gigabyte in a 30 gigabyte container. So that's actually something, a hackathon project that has been a lot of fun. And then the other thing that we want to do is HA everything. There's more stuff to do. All right, so I guess just to wrap up, the two things that I really would like to highlight that I guess the two biggest lessons for me in all this journey, I would probably summarize the first one as, just over-communicate. Anything that you want to do, you just got to explain the why you're doing it, the why it is important, and make sure, that you communicate to all levels, stakeholders, teammates, and whatnot, and especially on cloud outages. For cloud outages, it's very, very important, that you notify stakeholders, have frequent updates, and then share the postmortems. Now, processes were very important for us. As you saw, for each state, we were actually coming up with something new. And some of them actually were created kind of like in a natural way, but there were some others that, we thought, okay, yeah, we need this, and how can we do it, right? So, the idea here is that you got to make it official. So, just as a quick tip, just get started, write it down, get buy-in from the team, just circulate it, get feedback, and put in your wiki. Once you have something that you guys agree on, just make it, I guess, the law. And iterate. Nothing is perfect. So there were basically all the practices that I mentioned. The way that we work with the postmortems, the way that we did, even automated testing or the deploys and whatever. There were tons of iterations on all those items. And that's basically it.
Thank you.
Thank you.
Hi. Is it hard to manage a code base with a lot of feature flags? And which tools and practices do you use to make feature flagging cost efficient on your daily tasks?
So sorry, the first part of the question I missed. You said,
is it hard to manage code base with a lot of feature flags?
A database? Code base?
Code base, yeah.
Oh, actually, that's a really good question. So, yes, the feature flags definitely add a lot of complexity to the source code. You end up having some paths where you say, hey, if this feature is enabled, do this, else do this. So definitely, yes, that flexibility or the power of feature flags come at that cost. Not only that, there were many times that we used them only to hide work in progress. And then when we enable it for everyone, many times we would forget to go back and clean up the code and remove the dead path. That's something that definitely happened. Second part, yeah, sorry, could you repeat the second part?
Which tools and practices do you use to make feature flagging cost efficient on your daily tasks?
So not too long ago, what we actually did is we added a lot more documentation to the actual code file where we had the feature flags. We added a description, we added dates, and basically when we expected to remove it. So basically just like self-documenting the code, like how much we expected each feature flag to be there for. So that helped. Also, we started using feature flags in order to move features from beta, even beta that we showed to customers, to general availability. So we also involved other teams in the process. So whenever it was time to call a feature mature enough to call it GA, we took that opportunity also to do clean up and remove the dead code in the past. It's very messy though. It's still messy.
Hi, my name is Roman, and I would like to ask actually two questions because I can't miss the opportunity to ask a person who has bird's-eye view to the battlefield. So the first question is, there are a lot of tools to make leaf migrations for database and storage. What tools do you use for your environments in order to do these leaf migrations of the data? The other question is regarding the processes, and that's actually what we're working now with my team. And do you have any process of making technical proposals and introducing technical changes to the platform in DataRobot? Thank you.
Yeah, sure. So the first question was about the tools that we use in order to migrate databases or our data in our databases. That's also a really interesting question because we actually do not migrate data. Okay, that's a lie. We migrate data, but we do not have, I guess, scripts, in a typical database where you say, hey, I'm deploying from version 2 to 3, so let me run this script in order to migrate. We do everything in code. So basically, if we detect that this record is old, then we would add a new field, or we would do the change in the code itself. So we don't have, I guess, migration scripts. So the administration is very, very low from the database perspective. But then at the same time, again, the code can become a little messy whenever you have all this. So the migration that I talked about was basically just moving the data between two different replica sets that were part of the same Mongo cluster. So we did move the data, but there were not many changes to the actual data. All right, and then the second question is, what is the process for proposing new changes or basically new things in the platform, right? So we have a very open organization, kind of like a flat structure. We avoid management layers. So basically, everyone can suggest anything at any time, and everything starts with Google Doc. Write it down, share it, get your thoughts, and then basically just propose it. So that is, I guess, at a high level, how things get done in DataRobot. So there's an idea, it is written down, you get feedback, circulate it, and I guess the very last step is show the business value so we can actually convince stakeholders that we should be spending this time or this amount of engineers in that project.
First of all, thanks for a great talk. So, is that, if I understood correctly, you had a separate Python project for infrastructure management, then you moved to Ansible, and now you moved to Python project on top of Terraform.
Right.
So, what was wrong with Ansible actually?
What was wrong with Ansible?
I can probably may help answering Ulises with that. So everything is fine actually with Ansible. We continue using that project, but we separated the areas of responsibility since the Terraform is good to work with the cloud and to abstract all the work that we should do with the cloud. And Ansible is good to provision our software on top of that environment that Terraform prepared for us.
Yeah,
it's still in place.
We still use Ansible. I guess the only thing it was basically how we used it. It was definitely messy, and I think we were also using it for a lot of things. So only one part of it was replaced with Terraform, which was actually setting up the infrastructure, and that was super valuable. But the rest of the thing, the deployment and whatnot, that continued using Ansible.
Thank you, Ulises.
All right. Thank you, guys.
Thank you, everyone.